and welcome to today's webinar. Today we're going to talk about costing, and I believe some of you has been started to do some of the things in the costing, and SOLIDWORKS Costing, one of the big enhancement, by the way, in the past 3 years. So let's get started, and before getting started, please make sure that your setting is set up to microphone and speaker just to be able to hear me well. So our agenda for today is the general overview, what is the costing is about, and we will talk about how can we have the materials and thicknesses defined in the template, and how can we define the correct machines, the custom operations. So what is SOLIDWORKS costing? It's mainly automatic manufacturing cost estimations. So we can understand from the definition here two terms. The first term is manufacturing. So it's, by default, it's not included in the overhead cost. However, you can include the overhead cost as a ratio or a percentage inside your design, your cost. And it's estimation, which means that you are estimating some values at the beginning, and according to the equations and the calculations, it gives you another estimation. And this could be done for the sheet metal machine part costing. It could be done for any change, and it's very fast to update it, and it's customizable templates. So you can customize it according to your own, according to your machine that you have, the operation that you are doing. And it's working actually with any 3D CAD. It's not necessary to be, the part should be created by SOLIDWORKS or using SOLIDWORKS. So just to know that if you have SOLIDWORKS standard package, you would not be able to use SOLIDWORKS costing because it's included only in SOLIDWORKS Professional and Premium. And even the SOLIDWORKS assembly costing is included only in SOLIDWORKS Premium. By the way, we have our question area. So if you have any question even during the webinar, please feel free to ask. So who's using SOLIDWORKS costing? First, the designers, because they want to make a better design decision based on costing. And during the design phase, we have a lot of questions because we are receiving actually a lot of requests from the sales, from the marketing, and from the customers, our end customers, I mean. So can we do this and that? What about adding more feature to your design? How can we maximize the benefit and reduce the cost as much as possible? And as a designer, you have to answer all of these needs. And to do that, you have really to use a very fast way to do that in an estimated way, because it's still in the design phase. And also you need to get the cost estimated faster. You need to understand what design changes will help reduce the cost during the design phase. So what about the manufacturers? So they want actually, again, fast and repeatable, accurate codes. So when it comes to manufacturing, they need in each and every process. What about the cutting process? How much it does cost? What about the raw material? How much does it cost? And they need to have a coating based on their specific manufacturing process and labor and material cost. So normally the SOLIDWORKS costing is including a labor cost and material cost. And we will talk about that in details after a minute. So the managers and executives, they really need to have the product cost because they are cost targeted. So they are cost driven actually. So their target all the time is to reduce the cost and they need to maintain healthy and predictable profit margins. So before adding their profit, they need to understand what is the cost, and that's really a big problem nowadays in a small organization, in small companies, and even in the medium size. If I asked you how you most often calculating your cost, um, sometimes in the small companies you will tell me that there is a person downstairs in the accounting maybe, or maybe in the production facility, that he knows how to tell about the cost. So it will be approximately something like that. Or maybe he's comparing your current design with a previous design and measuring the cost of the two designs according to that, just comparing. So if he found, for example, a couple of holes added, he will increase the cost a little bit. If he found your design is very simpler than the old and the legacy data that he has as a reference, then he will reduce the cost estimation of your design. However, for managers and executives, that's really necessary to be accurate, because getting to the market is the goal. Getting to the market need to have the maximum quality ever possible and the minimum cost. And this is the real value from using SOLIDWORKS Costing, is to improve also the communication between manufacturing and design to reduce the product cost earlier. So what can we cost? What type of things that we can cost? So using SOLIDWORKS Costing, you can have a sheet metal part that has been cutting by laser and have bends and hems and forming tools. So all of these features and process and operations are included in sheet metal costing. And what about the machining? SOLIDWORKS Costing is including a milling, drilling, and turning. So it's a machined casting as well. So if you did a casting part and then after the casting you need to machine it, is that possible to have the cost in SOLIDWORKS? Yes, the answer is yes. So it's not only a removing material that's supported by SOLIDWORKS Costing, also additive operations are supported, like 3D printing, cast molding, and plastic injection. And about the multi-body and the assemblies and even the sub-assemblies, today in SOLIDWORKS 2017, we are supporting even the sub-assembly costing, not only the assemblies costing. So whatever you have a multi-body assembly or sub-assembly, that's also included in the costing. So how does it work and how to get it done? Let's talk about the real process. First, you need to understand the manufacturing process. Actually, this is the first step. So as a cost estimator, because working with the cost template and the cost stuff, in this case, your role is a cost estimator. You need to understand a little bit about your manufacturing process. So in the design, sometimes you will not need to have an overall look at the process. For example, you will not need to understand how long it takes from the welder to weld two pieces together. This type of information as a designer is not necessary for you, but as a cost estimator, it's a very mandatory information to know. And that's why you have to be included in the manufacturing process. After that, you have to build some equations and some assumptions. For example, how many hours are you working per week? And what could be the average cost of the labor in the workshop? So there will be some assumptions here to have it. And we will talk about some of these assumptions in a minute. And then you have to build your cost templates according to that. And you can use one of the cost templates that's inside SOLIDWORKS. However, I'm not recommending that because the cost template inside SOLIDWORKS is just a sample template. So you have to build your own. So you have to change all of the data inside the cost template that comes by default in SOLIDWORKS. And finally, after getting information of all of these processes, then you will get your estimated cost per part. And remember, this is the estimated cost per part and could be the total cost. And we will talk even about this section in a minute. So today, we will not be able to have all type of cost. We will just focus on sheet metal cost template. So what we're going to do next is to create a new cost, and I will use that simple part, which is a wall mounted shelf. And we're going to differentiate between the time-based versus the length-based. So let's get it started. I have here that part in SOLIDWORKS, and how can we initiate the costing? In the Evaluate Command Manager, you will find the costing directly. If we click here, we will get into the costing. First, we need to understand the method. Is it going to be a sheet metal or machine plate? The sheet metal is the part that we are designing, and the good thing about SOLIDWORKS Costing, because of your part has a sheet metal feature, the SOLIDWORKS Costing can understand directly what type of part is that. And here I have a part with a material ISI 304, and also we can look at the thickness. The thickness is 1.2 and the bend radius is 1.5. So just to remember this information, we will need it in a minute. Then the costing template, here I'm going to use a local template, and we can find all the templates that exist here. I'm having a lot of templates, and this is something that also we need to talk about it. How many templates that you could have for estimating a sheet metal part? Actually, you could have many templates. So don't worry about having many templates in your costing. So it's not only one template is enough, because maybe you're going to have one template for simple parts. You're going to have another template for complex parts. Maybe you will have a template for a specific operations and another template for completely different operations. So don't worry about creating many templates. It's just like creating a drawing templates. So you could have 10 of drawing templates for a part, for example, just to be easier to use them. So these are the templates that comes with SOLIDWORKS. And to launch that template editor, you can launch it from here. However, before going to the launch, how did SOLIDWORKS Costing define that? It defined directly using the sheet metal feature. So when you're creating a sheet metal feature, it's by default comes to a sheet metal method. No need to change it. And the costing template here, I did identify that we could have multiple costing template for multiple parts. Could be a simple part, could be a medium complex, could be a very complex part. And after that, you will, if you need to launch the template editor, you can launch it from here. However, we could start with costing options. So if we move to the costing options, you can identify the some of the values. For example, what type of templates that are going to be used by default for sheet metal? What type of quantities? For example, I don't need to have a 100 number of parts or the lot size is 100, I need to calculate it always for one single part. So, and also I'm recommending that at the early beginning, when you start your first costing template, is not to include that big number of parts, only calculated it in one part or one lot size. Then moving to the launching the template editor. So some of the options here, as you can see, you cannot change it, which is the metric standard and length-based cutting. And remember, these options could not be changed after creating your cut and bend operations. So after creating the cut and bend operations, you cannot change the units and input method. However, what I'm going to do is to create a new costing template, and this is the 3 types of costing template. I will select the template for sheet metal parts, and then once it's created, I will have the ability to change the units, and I will have the ability to get the input method. So the input method is length-based or time-based, and the real difference between that is in the time-based cutting, you can calculate the time to get this part manufactured. However, in the length-based, you will be able to use only the cost formula. So it will be based only the length, how long and how much it costs for the machine to cut this length. So I will use it at the length cutting, and I'll use my currency as EGP, and here we go. We have the Egyptian pound, that's fine, and I will not apply any discounts for my customers for the time being. However, I will be apply that after all. So again, remember, you cannot change some of the general settings after creating the operations. So back to what we have got. Okay, so we have created the new part, and it's a simple part, and we have started with the time-based. Then remember these assumptions, because we're gonna need it in a minute. As I said, I will not include the overhead cost. And I'm assuming that the operator salary or the wages of the one labor per month is 5,000 EGP. And talking about that, this is the total cost of the operator, it's not the salary actually. So this is the total cost of the operator, including his transportation, the allowances, the medical insurance, everything per month. And the working hours per month, I'm assuming that it's 175. The actual average actually is 173.3 or something, but I'm just rounding up the numbers. And then I'm assuming that the operator cost per minute is 0.6 EGP. I just make a very simple calculation. So if he did a 5,000 EGP per month, and the month including 175 hours, it means that we have to multiply the hours per minutes, converting the hours to minutes, and then calculate the cost. Good. So let's move in the material and the thicknesses. In the material and thicknesses, we will define the categories, and we're going to define the material, and we will discuss about the material weight versus the sheet size. Also, we will see that just to remember that sheet size dimension will be in meter, not in millimeter. So let's have that in action. Launching the template editor over there, and maybe I need to launch my template editor, so I need to save it first just to have a reference of that. So this will be a template version 1. Let's save it. Good. And then going to the material, first you have to add the classes. So I will use a stainless steel glass class. So this is the category of the material, and then I will assume that I'm using ISI 304. This is the material. However, if you are using, for example, another material like 316, so you have to add it as well. So the class is steel, and it's 316. It should be somewhere here. Okay, so it's stainless steel ferritic, for example. Yeah, 316, here we go. And so on. You can add more material. And this is actually the SOLIDWORKS material name. And moving to the thicknesses, you have to add the thicknesses for each and every material. So I will select the classes, and we will get the 304. And I'm using a thickness of 1.2 for the time being. However, we should add all the thicknesses. And the stock type, that's the very important. Are you measuring your stock type per weight or per sheet? Most commonly, the inventory people, the guys of purchasing, they purchase, or the supply chain department, they purchase per weight. However, when they apply it to the ERP system, they apply it per sheet. So in real life, you will know both of them. You should know both of them. So I'll assume that it's per sheet, and the X dimension of the sheet is the smallest edge of the sheet. And this could be, for example, 1.5 meter. Remember, the thickness is millimeter, and the dimension here is a meter dimension. So this is the longest edge of the sheet, and then you have to add the cost. Per sheet, I will assume that the cost per sheet, for example, is 24,000 EGP per sheet. Then I have to add the sizes again, so I'm adding the steel, and the thicknesses could be 1.2 as well. And I will tell you why I'm adding that again, because I need to change the stock type. So I will not measure it as a sheet dimensions. And instead, I will measure it with EGP per kilogram. So assuming that it's 200, let's say, 200 Egyptian pound per kilogram. This is the cost, the actual cost of kilogram of this material. And of course, you can have more to the data, for example, 1.5. So it's hard to add the data here. It's very hard to add it. And instead, you can, what you can do is to have that exported in Excel file and then get it back. So just type it in Excel. It will be very easy to do that, and then import it. Yeah. So this is 25,000. We good to go. Let's save it, and then we need to go to the cut operations. So back into the cut operations, we successfully added the categories of the material, and we did understand the difference between the sheet size and weight, and I will show you the benefits in a minute, and then the sheet sizes. Let's define the cutting machines. And before going to the cutting machine, we have to understand one concept, which is the setup time, because in the template, we will be asked about the setup cost. So what is the setup time? The setup time is including the time to change the machine settings plus loading the raw material plus the cam or whatever needed for the cam purpose from the operator side. So while the machine in the workshop, if you look at the time after unloading the material, actually this is also a setup time. So once the operator click stop or push the stop button to unload the material, till he's getting the cycle again to machine another part, all of this time you should consider it a setup time. And to understand the cost of this time, you have to understand how many laborers are there standing and helping serving the machine. And you have to multiply this time by the labor cost. Then in that case, you will be able to get the setup cost. That's simply the setup cost. First, you have to convert it to time, and then you will be able to have the cost. The second thing is the material weight versus the sheet size. This is actually cut from the other slide. The second thing, the real thing, is the cost per cut type. So we have some definitions here, which is machine hourly cost. I assumed that it's 400 EGP per hour. Actually, I did not assume it. I did calculate it according to some numbers. And to calculate these numbers, we can talk about that in maybe in a different webinar, because this is a complete cost estimation equations. So you have to calculate the investment cost, the fuel consumptions, the depreciation of the machine. A lot of things has to be calculated in there. Even the spare part, the maintenance, a lot of things has to be included. However, if you have a good accounting department in your corporation, it's very easy from them to give you that number. If you don't have it, you have to assume some values. For example, the price of the machine, the renting of the land, the cost of renting of the land that the machine is standing off. So, and the maintenance per year. A lot of parameters has to be calculated. And if you are interested, I can send you more information about that. However, finally, I assume that is a 400 HP per hour. Then the cutting speed, that's another parameter of the machine, because I'm defining a cutting machine. So this could be a plasma machine, could be a water jet, could be a laser machine. So I'm assuming a 50 minute per meter per minute. And the most fastest machine nowadays is maybe it's 80 or maybe 125. However, we are not operating the machine at the maximum speed, otherwise we will damage the machines. So I'm assuming the average speed actually is 50 meter per minute. And then the cost of operations. So after getting the hourly cost and after getting the speed, it's very easy to get this information by because finally we need to get it the EGP per millimeter. How much it costs to cut 1 millimeter of our part? That's the final parameter that we need to contain. So after making this calculation, I found that it's 0.48 EGP per millimeter. So let's see how can we add that. Moving to the templates, and then I'll go to the cut. And remember, the cut method is the name of your machines, simply. So I have, for example, Amara laser, and it's cutting type by length. It's not a stroke. And the setup cost, I'll assume it as 2 EGP. And I'm having, for example, a very powerful one, which is a Trump machine. And another laser machine, or maybe it's going to be a bunch machine, or could be a water jet, what type of machine that you have. So you have to list all your cutting methods here. And I'm assuming that a setup cost is maximum a little bit more, which is 3 EGP per lot. So remember, these numbers are per lot. So, and we assume that our lot size is only 1 part per lot. So we will not create that the equations to be multiplied or divided by. Because normally what SOLIDWORKS Costing is doing, as much as you are putting in the lot, so the setup cost has to be divided by the lot size to get the setup cost only for 1 part. For me here, I'm just assuming that this is the setup cost per 1 part because my lot size is 1 part. Moving forward, I'm having that type of material, 304, different thicknesses. I'm interested in 1.2 only, and this is the Amada laser machine, and I will put here my number, 0.48 AGP per millimeter. That's simple. Here we go. We finish with the cut. Back to the PowerPoint. Then we need, the next step is to define the bending machine. So we have 2 aspects here, which is selection type and the setup distribution. Actually, let's move forward to the bending machine, because in the bending machine, again, you have to type and list all your bending machines. For example, I'm having a Trump bending machine again. So it's Trump bending. And the setup cost again for that machine is the time. So it's similar to the cutting, it's exactly similar to the cutting machines. The time that needs from the labor after unloading the material, setting up the machine, writing up the codes, all of these are summed together until he load the material and then hit the press button. So from finishing the last operation till operating the next part. And the setup cost here, I will assume it that is 15, again per 1 part, and I'm having here, this is a 15 per all bend. So it's not for 1 bend, it's for the part. And then I'm having my material, the thickness is 1.2, and finally for the bend, you can easily calculate this cost, because if 1 bend is lasting for 20 seconds of the machine, which means that if you have hourly cost of 200 AGP per hour, it means that if you divide the 200 by 3,600, which is just to change from hour to second, it means that you will get this number, 0.05 AGP per bend. So that's the real value here, 0.05 AGP per single bend. Good. So let's get him back to defining a custom operation. So to define a custom operation, we have a couple of options here. First, you need to define the operation. For example, I'm doing an inspection per part, and That's why you have to set the selection type, because this should be a part. I'm doing an inspection for each and every part in my facility. That's my assumption. And the cost of that is 10 HEP. And actually, this is not including the setup cost. This is the total cost. There is no setup for an inspection. And in the setup distribution, which is a very important factor, you have to measure that is divided over the total quantity or the lot size or the per part. So this will be applied once per part or divided by total quantity. So I'm going to inspection each and every part in my patch. So I will apply that for over the total quantity. So it should be multiplied by the total quantities. So are we doing that always? Yes, I'm doing that always. Another one, which is the painting, that's a custom operation. And I will apply that for a face. And this will cost 2 AGP per millimeter square. And there is no setup cost. I will assume that the setup cost is including and hitting inside the operational cost. And this will be applied once per part. And it's not for all parts. And let's see how can that act. So saving my template and back to the part, and let's begin the estimation. And remember, at any time when you make a major change in your templates, remember to close and then get back to the costing. However, we can just get and hit that. So our costing now is 2,614 AGP. Ask yourself, does that make sense? Is it really a good number? Which means that I did not make any mistake in typing some numbers. For example, you may type it millimeter instead of meter, and in this case you will find this is a very, very large number, let's say. So let's discover some parameters here. So by default, it's including the classes, the name of the classes, and if you need to change from 1.2 to 1.5, that's also possible. And then this is the material cost. And if you do remember, we changed it, and we have 1.2 millimeter thickness that's added by a weight and a length, the dimensions. And that's why we can have a sheet size instead of material weight. So if you are describing the blank size and how much it takes from the sheet size, the current cost will be completely different. Remember, the last number was, let me uncheck that. The last number was 2,614 almost. And that second number here is 5,228. So why does that increase? It's increased because we applied the sheet size. And once you apply the sheet size, there is a very big factor that should be included here, which is the percent of scrap. So what SOLIDWORKS Costing is doing is calculating the percent of scrap according to the sheet size. And of course, it knows the blank size of the sheet metal part. And according to that, it's adding that to the cost. And from here, you can have the total number of sheets for lot size is 15. Because I'm applying here the total number of 100, so I don't need the 100. As needed is only 1. However, this is not. This is decrease the number dramatically. So if I need to increase the number more and more, I need to decrease the percent of scrap, and to maximize the number of parts per sheet. Look into that to show the bounding box nesting. So that's the current nesting. That's the current nesting that's happened now, because I'm applying only on one part. However, I will take his advice, SOLIDWORKS Costing advice, and applying 7 per part. And it seems that we decrease dramatically the cost. So it's not 25,000 anymore, it's 5,000 only. Because if you look at the bounding box, yes, SOLIDWORKS can able to nest all the parts. Of course, there are some parameters here, like if you need to have a margin, if you need to have a bounding box offset. So currently I'm leaving 2 millimeter between each one of the bounding boxes, and I'm not keeping any space of offset from the sheet border. So we have got a very good template, I can see. Good. How can we get the results? So I'm having here 2 results, the previous one and the current one. And to get the result, we always need to compare. So you can have multiple reports generated from SOLIDWORKS Costing. And to do that, so each time you are changing the part, it's need to generate a report of the costing. At the end of the day, you can compare between 4 or 5 alternative designs, or maybe alternative batches, as we will see now. So I'm going to generate a costing report. You can generate that as simple report, and the simple report will generate only 1 page, including only the material and manufacturing cost, and that's it. Then we can have it as detailed. The most appropriate one, which is Microsoft Word documents, and there is a very good option here. Alternate quantities. So in my example here, I did include alternate quantities of 7 parts per sheet. So what about a lot size of 50? What about of 100? What about F150? So I need to compare between them. So this is a good thing. Also, our assumptions could be included here, and the company information could be included here. So you need to fill in all of these data. Otherwise, your reports will not be that rich. So publishing that, let's see, the report. So remember that our part will cost 5,058 almost AGP per part. So what SOLIDWORKS Costing is doing now is to take in a screen capture, generating all the necessary data, all the breakdown of the cost, and finally you will have this report in less than 30 seconds. So you will have the model name, the manufacturing process, your sheet metal fabrication, the thickness, sheet size, all the information out there. And the good thing about it is the alternate quantities. So what will be the cost if the end customer will order 50 or 100 or 150? So this is the comparison. So as much as you are increasing the quantities, it makes sense to decrease the cost, which is good. Finally, we used the Word. We can, of course, we use the Excel format to do that, to have a code, to have a purchasing, how much does it cost, the production planning. So the report is not only a cost estimation for the codes. It could be used for purchasing purposes and production planning purposes. Finally, remember, it's all about cost estimation. So while estimating a good numbers, it means that you are getting a result of accurate number as much as you are estimating inaccurate numbers. Remember to get all possible data and assume the others. When you first started your costing template, I know that it would be very hard. I tried myself in multiple customers, and yes, it's hard to find the information. So try to find the possible information that you have, and the others that you don't have it, try to assume it. For example, you don't have the price of the machine. It's not a big deal. You can go to whatever Google and to look at the price of this machine, and you will be aware another in around between. And the third thing is it's a continuous process. So after getting a very simple part that like the one we did, it's necessary actually to continue improving. So do not stop there and tell yourself that, yeah, that's a very good template. No, that's a good template for this part, maybe. But what about the other parts? What about having extra and complex binding and other features? So you have to improve your template, or maybe creating another template. And finally, please get it started with your costing template today. It's very easy, and you can get whatever the information that you have learned from today's webinars, and you can put it and play with it until you get a refined cost. Thank you so much for your time. I believe we have got to the end, and let's see the questions. Do you have any questions? Okay. So it seemed that there is no questions. However, just to get back over there, that's my email. Please feel free to contact me anytime. Thank you so much for your timing, and see you in the next webinar. Goodbye.